Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I'm one of the event planners for the Redmond Reactor space. Before we get started today, I've got a few things to go over. So if you could please take a moment and read our code of conduct. Basically, what that's saying is that we seek to provide a respectful environment for both our audience and presenters. We encourage engagement in the chat, but we ask that you be mindful of your commentary. Please remain professional and, if possible, try to stay on topic. We're going to be sharing useful links throughout the chat, so please keep an eye out for that. And we want to let you know that this session is going to be recorded and will be available to view on demand on the Microsoft Reactor YouTube channel, and that should be available in about 24 to 48 hours after our session is concluded. So with that said, I would like to hand it over to Andrew, our speaker today, and he will let things get started.
Awesome, thanks for the introduction. So, hi everyone, thank you for joining my talk, and thank you to Microsoft and GitHub for inviting me to speak to you all today. In this session, we're going to cover a few topics. GitHub Advanced Security, also known as GAS, the rationale for doing security assessments, the OWASP DevSecOps Maturity Model, how we can use the DevSecOps Maturity Model with GitHub, and in that latter case, this will cover both manual and automated approaches to doing that. So before we get started, a little about myself. My name is Andy Dennis, and this is my second time speaking at the Reactor series. Outside of this virtual setting, I also run a number of DevSecOps related workshops at events ranging from B-sides around the country to Hope in New York City. I'm the VP of Platform and Cloud at Modus Create. This basically means I head up our consulting teams geared towards DevOps, cloud, security, and build systems. As part of my role, I oversee the partnership with Microsoft and GitHub from the delivery side of things. So we support both companies doing professional services type work. Finally, I've been doing this for a while now. Over the course of my career, I've held roles ranging from software engineering to DevOps, and then ended up in security. Now, a quick but shameless pitch about my employer, Modus Create. We're an end-to-end digital consulting platform who've been around since 2011. Our team is spread over 50 countries and handles work in several domains, including product development, platform, cloud and security, digital operations, strategy, and finally, data and AI. Within my practice, we do a lot of work in the Azure space, as well as GitHub. We're well experienced in DevSecOps work and helping customers handle build systems in relation to mono repos. So if you're a Bazel shop, we'd love to chat to you. Finally, Modus Create is a digital app and innovation partner with Microsoft and GitHub Copilot launch partner. Okay, so that's enough about me and Modus. Let's get into the meat of things and discuss the OWASP DSOMM. In the next section of this talk, we're going to cover who OWASP are, what the DSOMM is, and how it can be useful for measuring security from a DevSecOps perspective within your organization. Following this, we'll dig into GitHub and GitHub Advanced Security specifically. But first, let's ask ourselves a question. Why do security assessments matter? Modern software development is fast-paced, highly distributed, and increasingly dependent on open-source components. However, security vulnerabilities, misconfigurations, and compliance gaps often go unnoticed until they become major risks. Without a structured approach to assessing security, organizations expose themselves to breaches, data leaks, and regulatory non-compliance. So, security assessments help teams proactively identify weaknesses, prioritize risks, and ensure that security measures align with business needs. By embedding security checks throughout the development lifecycle, organizations can do a number of things, including reduce the risk of security incidents, improve compliance with industry regulations, build customer trust by demonstrating a strong security posture. Neglecting security assessments can lead to technical debt, costly breaches, and reputational damage, all of which are far more expensive to fix than prevent in the first place. So what are you going to learn today? To expand on the topics I mentioned in the previous slide, today we'll explore maturity measurement frameworks like the DSOMM, DevSecOps Maturity Model. The DSOMM provides a structured way to assess how well security is integrated into your development process, helping organizations such as yours benchmark and improve their security posture. GitHub Advanced Security. So this set of tools, including secret scanning, dependency scanning, and CodeQL, aligns with security best practices to help teams automate risk detection within their repositories. We'll also discuss automating DSOMM assessments with open source tools. So security assessments don't have to be manual and time consuming. We'll discuss how we can use the GitHub API to at least get a partial picture of how well we're doing. By the end of the session, you'll have a clear understanding of how to evaluate and enhance security in your development pipeline, reducing risks while maintaining agility. So let's discuss the OWASP DSOMM in enhancing security maturity. Who are OWASP? OWASP, the Open Web Application Security Project, is a globally recognized nonprofit organization dedicated to improving software security. OWASP provides freely available resources, including security standards, best practices, and tools to help developers and organizations build secure applications. It is best known for projects like the OWASP Top 10, the OWASP ASVS, OWASP SAMM, and frameworks like the DSOMM, the DevSecOps Maturity Model. So, what is the DSOMM exactly? The DSOMM is an OWASP framework designed to help organizations assess and improve their security practices in DevOps environments. It provides structured guidance on embedding security into software development, helping teams measure maturity levels, and most importantly, driving continuous improvement. What maturity areas and security practice areas does it cover, you may wonder? So the DSOMM evaluates an organization's security posture across many key areas of concern. And these include topics such as culture in organization, so security awareness, things like security champions, requirements, design and architecture, so threat modeling, secure design principles, and dependency management, build and deployment processes, so static and dynamic analysis of code base, software composition analysis, and security testing, and operations and monitoring. So here we can think of things like incident response, logging, and secrets management. These areas help engineering teams systematically implement security best practices across the whole of the SDLC. And what about GitHub security features? GitHub provides powerful security tools that align with the DSOMM framework, enabling automated and continuous security assessments. CodeQL is an advanced static analysis tool for identifying vulnerabilities in source code. Secret scanning can be used to detect exposed credentials before they can be exploited. Dependency graph and Dependabot identifies and automates dependency updates to reduce security risks. Security advisories track and address vulnerabilities and dependencies. Push protection rules prevent secrets from being committed in the first place. And security policy and enforcement allows teams to enforce security settings such as branch protection rules and signed commits. Each of these GitHub security capabilities maps to areas of DSOMM. We can think of some examples such as software composition analysis, which can map to GitHub's dependency graph and Dependabot, or static and dynamic analysis, which can map to CodeQL from a SaaS perspective. Secrets management can map to secret scanning and push protection. Logging and monitoring, we can use the security logs within GitHub to help address that area. And security testing automation. CI/CD pipelines, security can be handled via GitHub Actions. By measuring how well GitHub security settings align with the DSOMM, teams can assess their security maturity and identify areas for improvement. The DSOMM therefore helps to integrate security throughout the entire SDLC and DevOps process. We can think of other areas such as planning and design, where security awareness and threat modeling and secure design are important. Development, so secure coding practices and dependency management and testing. Static analysis, software composition analysis, and aiding incident response. So by using GitHub security features, DevOps teams can map DSOMM principles directly into their CI/CD pipelines, ensuring security is an integral part of the software development process from beginning to end. Further to this, to automate security assessments, organizations can use scripts running against the GitHub API, for example, to check whether key security settings align with the DSOMM recommendations are enabled. Examples here include checking repository security settings. For example, are you enforcing branch protection rules? Verifying Dependabot updates are enabled, ensuring CodeQL is active for static analysis within your repositories, testing if secret scanning and push protection has been enabled, and finally, if the team are monitoring security advisories and issue trackings. The benefits of using automated scripts are that teams can continuously measure GitHub security configurations against the DSOMM maturity levels, and we'll be looking at those momentarily, making it easier to track improvements and enforce security best practices across multiple repositories and across multiple organizations within your enterprise. In essence, by aligning the OWASP DSOMM with GitHub security capabilities and automation, you can systematically improve your DevSecOps maturity over time, reduce risks, and embed security seamlessly across your organization. So that's the OWASP and the DSOMM. I'm just going to run through some quick history around some milestones here. So the Open Web Application Security Project was founded September 9th, 2001 by Mark Curfy. It's a non-profit organization, and OWASP is dedicated to enhancing software security by providing free open source resources, including tools, documentation, and community-driven projects like this very one. They have a Slack channel as well you can go join, and they have meetups all around the world. The first release of the OWASP Top 10 was in 2003. This basically introduced the inaugural top 10 list, aiming to raise awareness about the most critical security risks affecting web applications. This list has become a foundational resource for developers and security professionals worldwide. The OWASP Software Assurance Maturity Model, the SAMM, was first released in 2009. SAMM provides organizations with a framework to evaluate and improve their software security practices, offering a structured approach to assess and enhance security throughout the software development lifecycle, and it complements the DSOMM. The DSOMM was later released in 2018, and the DSOMM offers a comprehensive framework to help organizations integrate security into the DevOps practices, as we talked about momentarily ago, enabling continuous security assessment, improvements, and rapidly evolving development environments. OWASP's Toronto chapter also released a talk combining the SAMM and the DSOMM, which you can find on YouTube if you're interested. Finally, the most recent OWASP Top 10 list was published in 2021, reflecting the latest research and data on prevalent web application security risks. This edition emphasizes emerging threats and provides updated guidance to help organizations mitigate these vulnerabilities effectively. The next release of the OWASP Top 10 should in fact be this year, so I think 2025 is our next update. So these two slides have given you the basic history and outline of DSOMM and OWASP. I'm now going to dig deeper. So earlier we noted the DSOMM is a framework designed to help organizations, and all of you on this call, assess and improve their security posture in a DevOps-driven environment. And as we previously discussed, it provides structured guidance on embedding security every stage of the SDLC, ensuring that security is not an afterthought, but an integral part of the software development lifecycle. Now, as its name alludes to, DSOMM aligns closely with DevSecOps principles, which advocate for automating security, integrating security teams into development workflows, and fostering a culture of shared responsibility. And one of the core principles DSOMM supports is the idea of shift left security, or shifting left as it's sometimes called, which means moving security checks earlier in the software development lifecycle. Traditionally, security was considered a final step before release, leading to last-minute fixes, delays, and security debt. With the DSOMM and the shift-left mindset, threat modeling is introduced during the design phase, static and dynamic analysis are embedded into the CI/CD pipelines, software composition analysis automated to track third-party dependencies, and secrets management ensures credentials are not exposed within repositories. By implementing these practices early, organizations reduce vulnerabilities, lower costs, and speed up secure software delivery. And this is where platforms such as GitHub can be used to help realize these goals. Let's quickly look at the graphic in the middle here. This is the OWASP DSOMM heat map, and it's a visual representation of security and maturity across 5 key domains of the DSOMM, and it's typically stored in a YAML file. So those 5 domains are build and deployment, culture and organization, implementation, information gathering, test and verification. Within these dimensions, multiple sub-dimensions exist, as shown in the heat map diagram, and we'll look at the website momentarily as well. Each security practice within these domains and subdomains is evaluated on a maturity scale, indicating whether an organization is at a basic, adopting, high, very high, or advanced security level. It will help highlight gaps that require urgent attention, partial implementation, or inconsistent application, or if you actually have well-established security practices in place. You can see an example of the heat map on the DSOMM website, so I'm just switched to that. This is a rather large graphic here, but if you were to click on any one of these areas, you're going to get a little box pop up, which will allow you to actually drill in and set a status. And when you select these, you can actually see that it will fill these in. And then you can actually download it here. Of course, you can also fork it and run it locally. You don't have to run it on the website. So feel free to take a look at that in parallel to the talk if you're interested. So teams can use these automated tools like we just saw on the website there and combine it with GitHub Advanced Security, OWASP Dependency Check, and custom API scripts to measure security settings against that framework we were just looking at, ensure that the concept of shifting left on security is effectively implemented. So the OWASP DevSecOps Maturity Model has a matrix view as well, which is a structured framework that helps organizations visualize and evaluate, enhance the security maturity across the various dimensions of DevSecOps that we saw in the heat map. It breaks down security practice into specific areas and allows organizations to assess their progress in a clear and structured way. So the DSOMM matrix is available on the OWASP website, and teams can explore each category, understand security impact, and determine what steps need to be taken for maturity improvements. So if I switch back to the website again, you can actually see if you click the link here on the left, and sorry, I know it might be a little small, this will actually bring up the whole of the matrix here. And many of these areas you can just drill directly into. So if I was to click this, it will take me off to a page which provides tons of information around the description, the risk, measurements, difficulty of implementation, and then references as well, which go after things like the OWASP SAM or ISO 27001 and similar. If I go back to this screen quickly, or back to the tab here, even since this is a zoomed in view, it's probably easier. We can see that those dimensions I mentioned, the build and deployment one, culture and organization, implementation, information gathering, and test verification are listed on the left-hand side. So these are the dimensions. And then along the top, we see the sub-dimensions, which is these ones here. And then we can see the maturity levels. So each of these criteria has information associated with it, which you can drill into if you're using the website. The DSOMM website therefore serves as an interactive guide where you can do a number of things. You can explore the DSOMM matrix in an easy to navigate format. So it's a little easier than clicking on the heat map perhaps. Understand the security maturity levels for each dimension and sub-dimension. So we have the 1 through to 5 here. Find recommendations on how to move from basic to advanced security practices. Benchmark your security posture against best practices. And then access open source tools and automation ideas to streamline security implementation. So by leveraging the DSOMM matrix and the website, you can create a roadmap for security improvements, integrate DevSecOps best practices in a structured and measurable way that's visually digestible, certainly when you're using the website. And the great thing is, as I mentioned, the code can be forked from GitHub and run locally, so you don't have to use the website itself. Great. So does everyone feel like they have a basic understanding of what the DSOMM is now? Hopefully. I'll take that as a yes anyway. Let's switch our focus back to GitHub specifically, and specifically GitHub Advanced Security, which we've been touching on briefly as we just talked through the previous slides. So GitHub Advanced Security, also known as GAS, is a set of powerful security features integrated directly into GitHub repositories to help developers detect, prevent, and remediate security vulnerabilities throughout the SDLC. GAS enables teams to automate security best practices without disrupting developer workflows. So let's look at some key features from a high level first. We have code scanning via CodeQL. This performs static analysis on source code to detect vulnerabilities. It supports a whole bunch of languages from C++ to Ruby. CodeQL is a query-based engine that identifies security flaws, and it helps developers fix issues before deployment. And if you have other tools that generate SARF output, you can integrate them into GAS so that they appear on the security dashboard. There's also the great autofix feature, which automatically creates pull requests with patches for vulnerable codes that it detects. And that helps to cut down on the remediation time as well. GAS also supports secret scanning. These features detect hard-coded secrets such as API keys, passwords, and tokens in the repo. And it's complemented by the push protection feature, which prevents developers from committing secrets, thus introducing new issues into the existing code base. And it also helps to reduce the risk of credential leaks and security breaches in the long term through its usage. We also have dependency management and supply chain security available via Dependabot. So the dependency graph automatically maps software dependencies, and then the Dependabot alerts and security updates notify when an issue has been detected, and it can also create automated pull requests so that you can patch it. And so these features combined essentially help to protect against supply chain attacks. Then we have other features such as security policies and alerts. And these enable organizations to define and enforce security policies across the repository. Dashboards provide visibility at scale of what's being detected, so at the repository level, at the organization, and at the enterprise level. So some reasons to consider on why GAS matters. It shifts security left by embedding security into development workflows. It automates vulnerability detection without requiring external tools. It protects software supply chains by securing dependencies, and it reduces security debt by helping developers fix issues early, and in many cases, helping to automate those fixes as well. So as you can see here, GAS helps teams really with that improving DevSecOps maturity, and we can start to see it aligns with frameworks like the OWASP DSOMM, which should aid in building more secure software within your team whilst leveraging GitHub's native ecosystem. So let's just dig into each of these 4 areas a bit more, because I think that they're pretty important and incredibly useful. As we explained, GAS offers a suite of security tools that integrate directly into the repositories, and that helps teams to automate that vulnerability detection and remediation in real time. This slide provides an in-depth look at 4 key components, including SBOMM, security scanning, Dependabot, and CodeQL. So what exactly is CodeQL? I had said it was a SaaS tool, and it is. It's a static analysis engine that scans source code for vulnerabilities before deployment. And you can see the scan results in the security tab for a repository within your organization. You can also see these results aggregated as well further up at the organization level dashboards or at the enterprise level. It works by treating code as data, and it allows developers to write queries that detect security flaws across their entire code base. So it will extract the code, turn it into an abstract syntax tree with some other interesting things under a term it uses as, a term it calls the database effectively, and then the queries are executed against that database. It identifies common vulnerabilities such as SQL injection, cross-site scripting, buffer overflows, and more. And the nice thing is you can write your own query packs too, or reuse others which are available out there in the community. So a bit more on how it works. It analyzes code across multiple languages, so JavaScript, Python, C++, Go, Java, and more. You can scan multiple languages at the same time within a repository as well if they're supported. It runs automatically in Actions workflow, or you can run it via the CLI. You can create custom configuration as well via YAML for the workflow, and that's where you can do things like add multiple languages if you want, or change the query pack. And as noted, security teams can create custom CodeQL queries to detect organization-specific vulnerabilities. You can also set CodeQL locally and use the VS Code plugin and CLI to work with it as well if you'd like to experiment with it and with query writing. You know, and all of this matters because it reduces security debt by catching vulnerabilities early. It automates secure coding within that CI/CD pipeline, and it helps you enforce OWASP DSOMM security testing practices. So what about Dependabot next? Dependabot helps detect, manage, and update dependencies automatically, reducing the risk of supply chain attacks, and also just outdated libraries being included. And its features include the dependency graph, which maps out the dependencies within your project. It has the Dependabot alerts, which notify developers when a dependency is known vulnerability. Like the scan results from CodeQL, these are visible on the security dashboard within your repository, so you can see all of them as a single pane of glass. It aids with those automated pull requests, where it will generate the pull request with a patch for the out-of-date dependency, so the team can then go in and follow standard practices to review it, test it, and then merge it in if it meets your needs. And there's also a compatibility score, which predicts whether updates will break your build, for example. So in essence, why does this matter? I think, you know, we've touched on it a couple of times. It prevents or helps to prevent those supply chain attacks by ensuring that the dependencies are patched. It saves developers time by creating those automated pull requests. And it strengthens OWASP DSOMM software composition analysis maturity. Next, we have the secret scanning portion. So the secret scanning detects hard-coded secrets, API keys, credentials, and tokens within repositories, and the scan results are also available via that security tab I've been mentioning. As we've discussed, push protection prevents secrets from being committed in the first place. This helps to avoid costly cleanup processes such as having to remove secrets and rotate them, run third-party tooling to clean the repo up or the history of it. All of that takes time, slows engineers down, so preventing the secrets getting in there in the first place is paramount. And the nice thing is, you know, it integrates with cloud providers. So AWS, Azure, GCP, and it can revoke exposed credentials automatically if it detects an active live key. So, how would you use it? You can run it on public and private repositories. It'll scan commits for those exposed credentials. And then you can have engineers leverage that push protection feature as well to block commits up to the repository. And ultimately, why it matters is it reduces accidental data leaks. I mean, we all know that people forget to remove .env files or perhaps leave test passwords hard-coded and things. And even though it's a test password, it may give access to a test environment. So it can help reduce the accidental leaks like that. It helps teams comply with this OWASP DSOMM secrets management best practices within the matrix. And it protects organizations ultimately from unauthorized access and security breaches. Then our last column here is software bills of material, so the SBOM. An SBOM is a machine-readable inventory of all the components, so dependencies, libraries, and similar, in a code base. SBOMs help track what software components are being used and whether they contain vulnerabilities. So within GitHub, SBOM features are available. The dependency graph and the API can generate the SBOM automatically, and there's also a button in there where you can download it. And the GitHub tooling supports the SBDX format, and that's an industry standard SBOM format. And for those of you who are interested in the topic as well, you can sort of extract that and then enrich the SBOM with VEX data, vulnerability exchange data as well. And this ultimately provides visibility into the software supply chain and any risks associated with it. So why does it matter? Well, it helps meet compliance requirements, especially Executive Order 14028, which is if you're supplying software to the government. It improves supply chain security by tracking all the various components you've been using. And it supports the OWASP DSOMM around dependency management, or OWASP DSOMM best practices around dependency management and doing risk assessments. So just some key takeaways from the slide. CodeQL automates SAST to catch vulnerabilities. Dependabot ensures dependencies are up to date. Secret scanning prevents credential leaks or detects them so you can clean them up. And then SBOM provide full visibility into that software supply chain. So GitHub security features, as we can see, align with the OWASP DSOMM, helping you integrate security into your DevSecOps workflows while reducing risk and enhancing compliance. So we just walked through GitHub's features, and I alluded to some of the ways it maps to DSOMM. So let's now switch back to that and sort of dig in and think about how you can do that mapping, because I think this is the most interesting part of the talk. To assess DevSecOps maturity using the OWASP DSOMM, we can leverage the GitHub API to map security-related features to specific subdimensions. However, the extent of automation depends on whether GitHub provides direct data, partial insights requiring manual review, or if external assessments are needed. In this last case, the subdomain might be out of scope of what GitHub can provide, for example. So can we find a feature via the GitHub API that addresses a requirement of DSOMM subdimensions? And the answer to that is yes. Some GitHub advanced security features directly map to DSOMM security requirements and can be fully assessed via the API queries. So I've got some examples here we can discuss. So let's take code scanning via CodeQL. That kind of maps to that static analysis requirement within the DSOMM. And we can use the API and we can run a get command against the code scanning alerts. And that will then check if CodeQL scanning is enabled and running. If we think of Dependabot and software composition analysis, once again, we can use the API and we can run a get against the API. And then we can verify if the dependency scanning and automated updates are in place. And then if we think about secret scanning and the push protection feature and how that maps to secrets management within the DSOMM, we can also use get to hit the API and confirm whether secret scanner is active and if push protection rules are enforced. And these checks sort of essentially fully automate some of that DSOMM assessment against your code base. Now, of course, if you're using multiple different repository or source control management tools, then you would have to do this for each of them. But if you have essentially moved everything into GitHub and that is your platform of choice, then it becomes much easier to run those scans against the whole of your code base and see what's enabled and what isn't. So does the API plus some manual review allow us to assess the subdimension maturity level for some of the things we saw in the heat map? And once again, the answer to that is yes. Some DSOMM practices require both API data and manual review to fully assess compliance. So branch protection rules is a good example. We can think about that as a security requirement that you may have. And we can use the API, to check if things are switched on and confirm it's enabled, but a manual review is still needed to assess if the rules align with perhaps policy requirements within your company. For example, requiring signed commits. When it comes to logging and monitoring, security logging, we can check the audit logs there, and GitHub provides those, but a manual review is required to interpret security events and correlate it with some of the DSOMM criteria. And then things like security awareness and champions, there's no direct API that can obviously pull that back, but commit activity and security setting reviews can indicate adoption and things like code owners files as well. So manual verification of training programs and internal security initiatives is still needed, but we can pull some data and perhaps use that to map them and combine them. Certain GitHub features, though, generate security-related data, but manual analysis is required to assess DSOMM compliance. So let's think of something like the security advisories feature, which you could hit from the API. That would list advisories, but reviewing response effectiveness requires manual evaluation. I alluded to code owners. Code owners and access controls, and when we think about secure design, we can take a look at the API and pull features back from that. We can check who has access, but policy enforcement needs manual review. And then when we're talking about things like GitHub Actions workflows and how that would map to security testing automation, once again, we can use the API, and that would identify workflows are in place, but manual review is needed to confirm security enforcement. So, for example, if you're using a third-party tool for doing DAST, or maybe a SAST third-party tool that covers IAC, you would need to just either double check that those are actually included in those workflows, or if they support SARF format, of pushing the data back to the security dashboard. So GitHub ultimately, it collects data, but interpreting effectiveness requires human evaluation in some cases. And then ultimately, are there some sub-dimensions that cannot be measured by GitHub usage? And of course, the answer to that is also yes. Some DSOMM maturity aspects are beyond GitHub's scope and require external tools, interviews, or manual reviews. So an example we could think of is threat modeling. There's no GitHub API that can assess threat modeling efforts, and that requires security team interviews and policy reviews. Or perhaps if people are using threat modeling tools, which saves the format down into JSON that they've committed up to the repository, so you can take a look. Security awareness training. Can't really measure that from GitHub activity alone. That requires broader interviews, perhaps with HR or reviewing training records. And then stuff like incident response playbooks. Sure, we could store them as markdown within the repository. And security logs exist, but playbook effectiveness requires manual tabletop exercises and process evaluation. So these areas will need external verification methods, and that's really beyond the GitHub API assessments. So some key takeaways. Some DSOMM aspects can be fully automated, arguably via the GitHub API. So checking if CodeQL is enabled, Dependabot's enabled, secret scanning is. Some require API queries and some manual review. So that would be, to confirm security settings aligned with maturity expectations. Some security data exists, but needs manual analysis. So security advisories or workflow effectiveness, make sure there isn't gaps. And then certain DSOMM dimensions just can't be measured on GitHub alone, and they require external tools and manual processes effectively. So using GitHub API automation plus targeted manual assessments, teams can continuously measure security maturity against the DSOMM and ensure that those DevSecOps best practices that we've been talking about are embedded effectively within your SDLC. So in this screenshot, you can see we have a spreadsheet where we've manually mapped some of the GitHub features that are available via the API to the DSOMM. And using this methodology, we can decide what can be automated, partially automated, and what requires manual intervention. So on here, we just used color coding for the various cells to say whether it was manual or whether it was fully automatable via the GitHub API. And then, of course, you could make that more granular, like partially as well, if you wanted. This can be a great starting point for figuring out how mature your DevSecOps implementations are. you can also use this to start thinking about how you would automate the process. So on the previous slide, I rattled off some of those endpoint ideas that you could use. So for example, using this spreadsheet, you could design a Python script to automate checking some of these subdimensions and then go use the documentation to figure out which API endpoints are the best ones to achieve that. So how do we go about writing a script? Well, we can do the following. Pick the language for scripting in. If you've got multiple teams who you plan on using and maintaining the script, pick a scripting language everyone's familiar with. I think that's fairly obvious. Make sure you have permissions in GitHub to access the API and the endpoints of interest. Otherwise, the script isn't going to work. So make sure you map that out when you're doing that spreadsheet to understand what you need access to and who needs access to it. And then use that spreadsheet as a guide to the information you want to collect. Next, you'll want to use the aforementioned spreadsheet to map out what you can and cannot collect. So by that, I mean, what's available via APIs versus what requires manual intervention or speaking to people outside of the scope of GitHub. Remember, you can always collect data that requires a hybrid approach as well, or needs manual review. So it doesn't have to be just stuff that's purely pulled from the API. Stuff that needs manual review, obviously you can gather that too. The final step is going to be the output format. So the DSOMM heat map that we saw, that takes a YAML file. So you could even directly output to that YAML file and then load it back into that the OWASP heat map there, and then go in and manually enter the things that require some sort of manual input. Or if you use other tools that accept JSON, for example, you can output it to that format, or load it into anything really. Build a Power BI dashboard or whatever visualization tools that you use in your place in order to do those compliance checks and measure data and metrics. Of course, if you don't want to write your own tool, we actually have an open source tool we're working on, which I'll be talking about now. So at the URL presented on this slide, you can find our own Python scripts we use for measuring DSOMM maturity. This project's in early days and is really just a prototype proof of concept. However, we plan to expand it and turn it into a nice installable Python package you can use in your own environments. It's configurable via a YAML file, and it spits out which checks you are complying with. And if you're so inclined, we'd love some extra help on it. So feel free to open an issue, fork it and open a pull request, or drop us an email with your thoughts. Let's take a look at the repo and learn a little more about it. So the repository is stored under the Tweag organization. Tweag is the name of our open source program office. So it's where a lot of our contributions back to projects ranging from Bazel can be found to open source tooling, talk material, you name it, it's all here. So we've just got a little bit of an outline here about what the DSOMM is and a snapshot of the heat map we showed everybody. And you can find a list of the features here as well if you're interested. Just some background on the requirements. You'll need Python running. You'll also need the GitHub CLI. And as I mentioned before, having it set up so that you can authenticate with the GitHub API is important, and having the right permissions. In this case, write admin permissions are required to query the repository data. So some thoughts on supported checks. As I noted in this talk, some DSOMM checks can't be automated and therefore not supported due to the nature of the check. So they need to be replaced with interviews or some other methodology. However, some features in the future may become available. So checks may be updated as available via the GitHub API to keep checking back on this repository, and we will post the updates here. So the support checks for each DSOMM level, we've broken them out here in the documentation. There's a link to the individual script that you can run, which will then tell you if it's a yay or a nay, and a description. And these are broken down by the levels as well. So level 1, level 2, level 3, level 4, and then finally level 5. To extend or enable support for new checks, you can create a new Python module in the checks directory, implement the check function in the placeholder file, and then update this DSOMM-checks.yaml to include the new support set to true. And if I click on this, you can just quickly see what this looks like. So we've got all the levels listed here, and then you can just add them in. So if it's not currently supported, it's set to false. If it is, it's set to true. of course, if you're taking this, forking it, and building your own version around this, you may have another mechanism you can, define the build process is set to true via something you're doing in GitHub via action. So feel free, to customize it as you need. If I go back to here again, so excuse me, sorry. Scroll down. So let's take a look at some of the example runs. So you can see here, you can execute this from the command line using Python 3. Just hit this main.py file, and it will give you this little prompt, and it will show you the available checks. So what's supported and not supported, which is what I just drilled into on that YAML file a moment ago. And then that is once again broken out by each level. So there is something like, I believe, 172 different checks it can run. And then you'll get some options around, if you want to run all of them or if you want to run a handful and similar. The output format at the moment is just tabular and CSV. I'd love to get this updated as well to output the YAML for the heat map and also JSON. And then also where you want to output this. So you can stick this in the CSV file locally or wherever you want it to be. And then if you're curious, this is how you can just run a subset of the tests as well. Here's an example of the output in a tabular format, so just showing whether it's supported or not. Okay, let's scroll down. And then finally, at the bottom here, there's some information on just troubleshooting. And if you do have issues, take a look at that and just make sure things like your YAML file are properly formatted. There isn't extra white space or similar. So that's the repository. I hope you have fun digging in there and kicking the tires. And once again, if you have any feedback or you would like to commit features or fixes, please go ahead and do that. And we'll switch back to the slides. So while GitHub Advanced Security and the GitHub API provide significant coverage for assessing security maturity under OWASP DSOMM, some gaps may remain. These gaps can be filled using third-party GitHub technology partners, open source tools, Microsoft security solutions, and reviewing GitHub's ever-evolving roadmap for new features. Many GitHub marketplace partners offer security-enhancing integrations that complement DSOMM assessments and enrich GAS. So on the DAST front, we can look at StackHawk, who offer a dynamic analysis tool and an API testing discovery tool. This helps organizations expand scanning by testing running applications in real-world attack scenarios, effectively with DAST. We have enhanced secret management, so you could use Azure Key Vault, which provides integrated security management beyond GitHub's built-in features. This helps organizations secure secrets across multiple repositories, environments, and cloud infrastructure. So using technology partners, teams can bridge GitHub API limitations and improve DevSecOps maturity alignment. We can also fill the gaps using open source tools. So open source tools can complement GAS capabilities, filling in some of these DSOMM gaps where the API coverage is limited. So threat modeling and risk assessment. So we can use OWASP Threat Dragon. Obviously, at the moment, there's no way of doing threat modeling within GitHub, but this tool can be downloaded and executed locally, and you can do threat modeling diagrams and save it up to a location where the team can review. And this supports threat modeling efforts across application development effectively. We can look at software composition analysis on the open source side of things. There's OWASP dependency check, commercial tooling, Endor Labs is really great. That integrates with GitHub Advanced Security, pushes SARA files up, has support for Bazel, so that's another option. And in the case of open source and commercial tools, really, they can provide SBOMM generation and vulnerability tracking beyond what Dependabot's capable of doing, or enrich what Dependabot's doing. We also have automated DSOMM compliance checks, so running something like the Open Policy Agent and related tools, or InSpec. That allows custom policy enforcement and security best practices to be enforced. So by integrating open source security tools, teams can cover security domains not directly measurable through the GitHub APIs. So this complements everything we've said about you can do automated reviews, you can do sort of partially automated, manual, things out of scope. Using some of these other gap filling mechanisms, you can sort of enrich what you can do via automated fashion. Then something else to think about is reviewing GitHub's roadmap for future features. So GitHub continuously expands security capabilities, and they will address some of those DSOMM gaps over time. So how to stay updated, you can monitor the GitHub roadmap. It's out on their website for new security features, and then track all the various GitHub discussions and community feedback to understand what security enhancements are coming down the road. And that includes going to things like the Galaxy event and GitHub Universe. So I would say examples of GitHub features that have recently been added that support GAS, the push protection feature for secret scanning, and then the campaigns dashboard, if any are familiar with that, gives you fantastic mechanism for organizing how you address some of the vulnerabilities you've detected in your code base. So by tracking GitHub's roadmap, you can align future security assessments with upcoming features. So that idea of the DSOMM being something that is around maturity, so you want to continuously sort of self-assess and execute it, you can use the roadmap to help find out how you can plug certain gaps in the future. Then something else to think about is complementary GitHub security tools with Microsoft security tools. So since GitHub is part of Microsoft and effectively, part of the same integrated environment in many cases, security tools can enhance DevSecOps maturity by integrating with Microsoft security solutions. So any of you out there who are using ADO, you can use GASDO, for example. We also have Microsoft Defender for cloud DevOps, which extends GitHub security insights across multi-cloud environments. Microsoft Purview, which can assist with compliance, data security, and risk management. We've got Sentinel, which integrates with GitHub security logs for a SIEM-based monitoring and incident response approach. And then Azure Key Vault, which provides enterprise-grade secrets management, complementing what you can do with GitHub's secret scanning. So detect an issue, pull it out of the code base, rotate it, and then start using Azure Key Vault, for example. So by combining GitHub security tools with the Microsoft ecosystem, you can expand security capabilities beyond just what's possible with code repositories and GitHub itself. So today we explored how OWASP DSOMM, the DevSecOps Maturity Model, and GitHub Advanced Security GAS work together to enhance security in modern software development. What does this mean for your DevSecOps journey? You can automate security assessments by leveraging GAS and GitHub API to gain insights in where you are. You can continuously improve security maturity by aligning with DSOMM best practices. You can fill security gaps using third-party integrations, open source tools, and Microsoft solutions. So by combining OWASP DSOMM with GAS, you can basically shift security left, reduce risk, and build secure applications faster. So on that note, thank you all for attending. And if you have any questions, I believe we've saved some time at the end to answer them. And if I can't answer anything now, please drop your email in the chat, and I will be more than happy to get back to you or pull in one of the experts from my team too as well. So back to you.
We did have one person asking about your slides, so I'm not sure if we can make those available.
Yes, absolutely. What I will do is I'll export the slides in a PDF format, and then I will upload them to the repository. So I will put them in here, and then you will be able to download them from, I'll create a directory called slides in here, okay?
Sounds good. Sounds good. All right. Well, Andy, thank you so much. We really appreciate all your insight today. And I'm sure everybody else appreciated it as well. And with that said, we are promoting our upcoming AI tour. So if you are in one of these cities or will be around one, we definitely encourage stopping by and checking it out if you've got the time. So I appreciate that. And once again, we always are open for feedback. So we would love to hear what you have to say. If you'd like to give us any ideas or thoughts about our next episode, we'd appreciate that. And the main thing you want to do is reference today's event code, which is 24738. Once again, that is 24738. Thank you all so much, and we will see you for the next episode.